All right, welcome back. We're going to solve the exact same problem now, except for we're going to call it a differential equations problem. Okay, so let's take and solve y e to the xy plus 2x dx plus x e to the xy minus 2y dy equals 0. Okay, so we're going to call p of xy equals y e to the xy plus 2x. Q of xy equals x e to the xy minus 2y. All right. Partial of p with respect to y equals partial of q with respect to x. And if you don't believe me, see page 1 of these notes. Okay. The integral of p of xy with respect to with respect to x equals e to the xy plus plus x squared plus some g of y. Okay. The integral of q of xy with respect to y equals almost the same thing. E to the xy, this time minus y squared plus some h of x. And you put these together to get f of xy equals e to the xy plus x squared minus y squared plus c. Okay? So really what you're actually doing, another way that you can think about this is that your solution is going to be e to the xy plus x squared minus y squared equals c. This is actually the solution. This is granted it's an implicitly defined solution, but it is a solution to this differential equation. Okay? So now let's take a look at a couple of others. Okay. So let's solve the same way. Two x plus y squared minus cosine x plus y dx plus 2xy minus cosine x plus y minus e to the y dy equals 0. Okay, so let's call this one P. Two x plus y squared minus cosine x plus y. And this one we're going to call Q. By this one, I mean this one we're going to call Q. So Q of xy equals 2xy minus cosine x plus y minus e to the 1. Okay, it took me an embarrassingly long amount of time to realize the p goes with the dx and the q goes with the dy, and the way to remember that is that it's alphabetical. X goes before y, and p comes before q. Okay, that's that simple. Okay, so let's check partial of p with respect to y. Partial of p with respect to y is 2y plus sine x plus y. Check. Partial of q with respect to x equals 2y plus sine x plus y. Okay, so these are equal. So we have an exact equation. So our f of xy on the one hand equals the integral of p of xy with respect to dx. On the other hand, it also equals the integral of q of xy with respect to y. Okay, so let's go ahead and calculate both of those, and then we'll find our f. Okay, so here we have integral here with respect to x is going to be x squared plus y squared x. Integral of cosine, remember, is the integral of sine, or I'm sorry, is sine. So minus sine x plus y. Now, since this integral is in x, there's going to be some arbitrary function of y. Okay. Next line, we're going to take the integral here with respect to y. Okay. Integral here with respect to y, so this is going to be xy squared, right? Because the squared, the dividing by 2 and the 2 cancel. Minus sine x plus y minus e to the y plus some function of x. Ooh, I did that in orange earlier. Let's do it in orange again. Now, one thing to notice is that if there are terms that are shared that have both x and y in them as in a multiplicative sense, they need to be the same, okay? Same here, the sine of x plus y. If I didn't have a sine of x plus y here, but I did here, then I would know there's a problem. Okay, I made a mistake somewhere. Now, I didn't, of course, because I'll never make mistakes. That's not true. Some of them might even find their way into videos. Okay, it's just how it is. So f of xy equals, let's write it as y squared x minus sine x plus y, those are shared terms, plus x squared minus e to the y. And then our solution is going to be y squared x minus sine x plus y plus x squared minus e to the y equals a constant. Okay, so you might ask, well, how do we find the constant? Where does that constant come into play? You don't ask that? You all get that? That's what I thought. Okay, well, the next video, we're going to talk about doing these as initial value problems, and then that's where we'll see where this constant comes in. Okay? So I'll see you shortly. Or actually, you'll see me shortly.